Okay, so now for question 5. Question 5 is our probability question. In this case, usually it's question 6, but all answers must be calculated, factorial answers. They just show you what they mean. And then let's start. Events A and B are independent, and events B and C are mutually exclusive. Now, what does that mean? As again, if you don't know your theory, you won't be able to answer your questions. So if something is independent, it means that when we multiply their probability, we get the same answer as when we look at their intersection. So that's what that means. If something is independent, that's what that means. Okay, this is true. If something is mutually exclusive, so for example, in this case, B and C is mutually exclusive. So PB and C is mutually exclusive. What that means is that it's B and C. P, B, or C. Okay, their union, this is what we call union, that's what we call intersection. The union is the sum of the two. Okay, now usually what is always true is that the union is equal to the sum. I'm sorry, this is, I don't know what I'm doing there, B and C. Okay, sorry about that. The union is the sum of the two events. The probability of the union is the probability of the sum minus the probability of the intersection. Okay, this is always true. You can always use this information. And the only thing is that when something is mutually exclusive, that means mutually exclusive means they have no intersection. In other words, the probability of them having an intersection is equal to 0, and that is why this is true. Okay, so with that in mind, I looked at the two students' attempts. The student said here, the questioner asks, if P, A, and B, in other words, the union of A and B is given by that, and PB is given by that, determine PA in terms of A and B. Now, this student got it correct. Here, correct answer. PA is A minus B. That's perfect. Okay. So for example, if P, A, and B is equal to A squared minus B squared, and we already know that PA, or is it PA that they gave us? PB is given. PB is A plus B. And we also know, so this is the information that we know. We also know that they are independent, which means that PA and B, the intersection is equal to PA times PB. And so PA is now given as A squared minus B squared. PB is now given as PA is what we're trying to find. PB is given as A plus B. And so to get PA, I just divide both sides with an A plus B. A plus B. So PA is then equal to, and then to simplify this, I obviously have to factorize. So the top goes A minus B, A plus B, over A plus B. And then the A plus B cancel, and that's why PA is equal to A minus B. Okay, that's the first part. Determine PB or C in terms of A and B, if PC is equal to 3PB and P. Now that sounds so confusing, like as if you somehow have to do it in your head. Guys, you don't. Just write down the information. So let's start by saying, well, they're now asking they're asking us to determine P, B, or C. Now, what do we know? P, B, or C is equal to PB plus, well, this is always true, PB plus PC minus PB or, B and C. Minus PB and C. But we knew that PB and C, they are mutually exclusive. That mutually exclusive means they have nothing in common. So they have no intersection. So this is equal to 0. Then now they give us, okay, and PC is equal to 3PB, and PB is A plus B. Okay, like in the previous one. So let's first substitute this. So PB is, PC is 3 times as big as PB. So in other words, this is 0, so there's nothing there. So I have 4 PB. And now I know that PB is A plus B. And even that's your final answer. Okay. Consider 3, again, it's very important that I know my theory. Consider the digits 3, 4, 5, 6, 7, 8, and 9. If repetition is allowed, how many 3-digit numbers can be formed? Okay, so I want a 3-digit number where I can use any number between 3 and 9. Let's first see if the students get it correct. Okay. First, this student said 9 to the power of 3. That would have been correct if there were 9 digits. It's not 9 digits. It's from 3 to 9. So there is 7 digits. 3, 4, 5, 6, 7, 8, and 9. So it's 7 to the power of 3. Okay. The student said I don't know if the student is just using factorials. Okay guys, let me just explain. We have 3 boxes here that we want to fill. 3 digits. How many options do I have for this box? 7. How many for that box? Well, I'm allowed to repeat, so I can use any one of those again. So I've got again 7. How many do I have for the last box? Again, I'm allowed to repeat. I've got 7 digits. So that is 7 times 7 times 7 is 279. Okay, so it's really, really simple. How many 5-digit numbers can be formed if repetition is not allowed? Okay, so this time I've got 5 boxes to fill. I don't know why I like saying boxes to fill, but that's how it's always made sense to me. For the first box, I can choose any number. So there's 7 options to choose from. For the next box, I can choose out of 6 because I've used 1. I can't repeat whatever I used there. For the next one, I only have 5 to choose from because I can't repeat what I've used in these 2. Then I have 4, and then I have 3 because each time I have 1 less to choose from. So the number I can choose from is 7 times 6 times 5 times 4 times 3. Okay, And you could use your calculator. Let's see. 7 times 6 is 42, times 5 is 210, times 4 is 840, times 3 is 2,540. 2,520, yeah. 2,520. Okay? Let's see. 9 times 8 times 7. So this student would have been correct if she just realized that we don't have 9 numbers to choose from. We had 7. And please don't use commas, but you're on the right track. And then this student, 5.2.2. 5 times 9 times 8 times 7. It's very close, similar, but just remember that it's not about the digits. It's got nothing to do with 9. It's got it has everything to do with the digits. It doesn't have anything to do with the value of the numbers that I'm putting in, because they could have said I'm putting in numbers from 21 to 27 or from 14 to 21 or whatever. It's all got to do with how many are there that I can substitute. Okay, how many numbers between 6,000 and 7,000 can be formed if repetition is allowed? Okay, now guys, notice what this is. It's got nothing to do with the values. What it's got to do is it's got to do with the digits. Okay, so there, how many numbers between 6,000 and 7,000 can be formed? Now, if a number is between 6,000 and 7,000, it means the first digit is a 6. And so there's 4 more places to fill. I'm allowed to do repetition. So in other words, I can use any number between 3 and 9 here, which means I've got 7 options here, 7 options there, 7 options there, and 7. I don't have 6 options here. I've got 1 option here. I've got 1 option there. It must be a 6. But for the rest of the digits, it can be any of them. So it's 1 option for my first digit has to be a 6. Then it's times 7 times 7 times 7 times 7 is equal to 7 to the power of 4, and I think 7 to the power of 3 is 243. 7 times 7 is 9 times 7, yeah, 743 times 7 is 14 plus 28 is 168, so it's 1701. I think so. I'm trying to do this in my head. I don't know it off my head, but 7 times 24, it looks more or less right. I don't know, use your calculator. Well, I suppose I can. 7 to the power of 4, 2401. Oh, sorry, I'm what? Wait, what? Um, 7 times 2. Okay, sorry, I have that way wrong. 2401. Sorry about that. Okay, nevertheless, that's it. That's it, guys. Really, this one is a problem-solving question. It's not a difficult problem-solving question, but so really, there's no reason why you shouldn't get 3, 6, 8, 3, 6, 9, 11. There's no reason why you shouldn't have gotten 11 out of 14. The rest was really straightforward, routine and knowledge questions. Okay, question 6 up next.